Today we're going to look at graphs of equations. So we're going to start with points and then we'll move on to more of these graphs. So the first question is asking, do the points 2, 13 and -1, -3 lie on the graph of y equals 10x minus 7? We recognize that this is an x, y point. So I'm going to put those values in, the 13 for y and 2 for x. And I want to know, is this a true statement or not? Does 13 actually equal 10 times 2 minus 7? 10 times 2 is 20 minus 7, and yeah, 20 minus 7 is actually 13. So for that reason, yes, I can tell that that point is on the graph. Let's check our next xy point. Let's see if the y value, -3, actually equals 10 times the x value, minus 7. So 10 times -1 is a -10 minus 7, which -10 minus 7 is -17. So actually, this is not true. For that reason, no, this does not actually lie on the graph. The first one, yes, did. Now let's look at sketching the graph of 3x plus y equals 7. And this is a straight line, so really all I need are 2 points. In fact, I'm probably going to substitute in the easiest number. I'm going to probably start with 0. And I'm subbing that in for my x value. So I get y equals -3 times 0 plus 7. -3 times 0 is 0, plus 7 is 7. So my y value is 7. And that was when my x value was 0. So I've got the point 0, 7. So I plot that on my graph, and I need a second point in order to graph this line. Really, I can pick any of these. Maybe I'll substitute in a 1 this time. It doesn't really matter which of these you pick. So I get -3 times 1 is -3, plus 7 is 4. So my y value is 4, and this was when I substituted the x value of 1, the 0.14. So I'm going to plot that 1, 4 on the graph. And truthfully, I can, draw a straight line through these now. To make it even more accurate, I can get, many more points. Maybe I'll just get a negative value here. Let's just try this one. Y equals -3 times -2 plus 7. So -3 times -2 is 6 plus 7. So we've got a 13 for our y value. And that was when the x value was -2. So the point -2, 13, which is kind of off the graph here. I don't have any higher y values, but it does make sense. I would go -2 up to a 13. So it looks like it should kind of be on this line. So they are asking me to sketch a graph of this line, which I did. I can see the y-intercept. The y-intercept is the point 0, 7. What I can't see is the x-intercept. I know it's somewhere around here, but exactly which one, I'm gonna have to do a little algebra for that. My x value was 0 when I got my y-intercept. I am now going to make my y value equals 0 when I get an x-intercept. So in this equation, I'm going to do a little algebra here. 0 equals -3x plus 7. So I will solve for x. Subtract 7 on both sides, divide by -3 on both sides, and it looks like I got this positive 7/3. Not a very pretty number, but I did find the x value, and I know that the y value is 0. So there's my x-intercept. 7/3 is a little over 2, which it looks like it would be still on this straight line. Okay, let's look at sketching our next graph. When I had a straight line, all I needed were 2 points. This is not a straight line though, because you can see the x squared here, you can tell it's a parabola. In fact, the -2 has shifted our parabola down 2, so I know it should be looking something like this. Let's get some specific points though. So I'm going to start by substituting in my -2 for my x. Y equals a -2 squared minus 2. Now, please use these parentheses. That means the entire -2 is all squared, which a negative times negative gives me a positive. I got a positive 4 minus 2 is 2. So there's my y value when I substitute the x value of -2. So the point -2, positive 2, there goes on my graph. And next up, I will substitute in a -1. So -1 squared minus 2. Again, -1 times -1 is a positive 1. Minus 2 is -1. And that was with the x value of -1. So the point -1, -1. And then subbing in a 0, I get 0 squared, which is still 0. Minus 2, so a -2 for my y value. That was when I substituted a 0 for my x value. So I got the point 0, -2. And that's the vertex, so I can kind of tell it should be the same thing on the other side. I should get these points 1, -1, and 2, 2. But we'll just check and make sure. When I sub in a 1 squared minus 2, 1 squared is 1, minus 2 is -1. So I did get the point 1, -1. And then let's see if I get this one. When I substitute in a 2, 2 squared is 4 minus 2 is 2. So my y value is 2 when my x value is 2. So the point 2, 2, yeah, there we go. We're going to connect these dots for our parabola. And I can actually see the y-intercept again. My y-intercept right here is the point 0, -2. As for the x-intercepts, it's kind of hard to tell. It's something right here and right here. So I can tell I have two x-intercepts probably between 1 and 2 and between -1 and -2. But I can't tell exactly what those numbers are, so I do have a little algebra to do. Every time I have an x-intercept, my y value is 0, so I'm going to make this y value here a 0. 0 equals x squared minus 2. So I will add 2 to both sides, and to get rid of this exponent, I have to do the inverse operation. I have to do a square root on both sides. So I get a square root of 2, and because of the square root, I have to have a plus or minus, like I get a positive and negative root 2. So this actually means I have two different x-intercepts. I have positive root 2, 0, and negative root 2, 0, which I can see that on the graph. So let's look at the next one where we don't actually draw the graph. We're just going to do this all algebraically. The x-intercepts always have a y value of 0. So I'm going to do some algebra, so a 0 in for that y. So 0 equals the x cubed minus 4x. And I've got to solve for x. So I'm going to factor out an x. I have x squared minus 4 now, and I'm also going to factor my x squared minus 4 into an x plus 2 times x minus 2. If you don't remember from last year, this is the difference of squares. So we end up, the square root of 4 is 2, so I got an x plus 2 and an x minus 2. Now, in order to equal 0, I know that anything times 0 is 0. So if this x is 0, then it would be 0 times whatever is still 0. If the x plus 2 equals 0, then 0 times whatever this stuff is still 0. Same for the x minus 2. If x minus 2 equals 0, then 0 times all this stuff is still 0. So I've got an x plus 2 equals 0, and I have an x minus 2 equals 0. To solve for x, I get x equals -2 and x equals +2. So that means I found 3 different x values. That means I have 3 different x-intercepts. We've got 0, 0, because we found an x value of 0. We've got -2, 0. Again, we found an x value of -2. And we've got 2, 0, again, because we had an x value of 2. So those are our 3 x-intercepts. So let's find the y-intercept by setting our x equal to 0. So y equals 0 cubed is still 0, minus 4 times 0, also 0, and 0 minus 0 is 0. So we end up with a y value of 0, and the x value is also 0. Every time we have a y-intercept, our x value is 0. So the point 0, 0, which honestly we kind of knew of over here, and it hits both the x-axis and the y-axis, so we kind of knew that was going to be our y-intercept, but we found it algebraically as well. So here are the 3 x-intercepts and the 1 y-intercept. Now to check your answer, you can put this on a graphing calculator, you can put it in Desmos or GeoGebra, and check and see if you got it right. Okay, so I'm looking at a graphing calculator, and under the y equals menu, I'm going to enter our function x cubed minus 4x, and as I graph it, I'm looking to see if I have the correct intercepts, which, okay, it looks like I have 1, 2, 3 x-intercepts, and then it hits 0, 0 for a y-intercept as well. So this is a good way to look and see if I got the correct answer. So now the last one says, find the x and y intercepts of the graph y squared equals x minus 2. So I'm going to do this pretty much the same as I did before. I will look for my x-intercepts by setting the y values equal to 0. So it'll be a 0 squared instead of y squared equals the x minus 2. 0 squared is still 0, so I will add 2 to both sides. 0 plus 2 is 2, so it's when the x is 2 and the y is 0. And it looks like I just had that one x-intercept. Next up, our y-intercept. This is when the x value is 0. So I have y squared equals 0 minus 2, which 0 minus 2 is -2. And I get rid of this exponent by doing a square root. That means I get y equals the square root of -2. And if anybody put this in their calculator, there may be kind of an indicator that there's a problem here. So now my calculator, I'm doing the square root of -2, which it tells me there's an error. Like this number does not exist, and that's because it's an imaginary number. So if the square root of -2 is an imaginary number, then that means I have no y-intercepts. And we can check this out on the graph to see if we got it right. So this is my graph on GeoGebra. You can do the same thing on the graphing calculator. Because it says y squared, I personally think it's a little easier on GeoGebra or Desmos. So this is my sideways parabola, which I can see that I have a single x-intercept at the point 2, 0, and that I don't hit the y-axis at all, so I have no y-intercepts. All right, I hope that's helpful for you guys. Have a good day.